So number, we have real number and complex number or imaginary number. So all the number we're dealing on the paper, or you can count, or you see that actually exist in nature, they're real numbers. Okay? So what are imaginary numbers? Imaginary numbers, they're just numbers that cannot exist naturally. Okay? So within the real number, we have several sets of numbers. If you look at your book, and then you look at your Venn diagram, what's a Venn diagram? You know, in your book, in a circle, that's your Venn diagram. So, we have real numbers, okay? Assume the entire box is real number. Within real number, we have two different subsets. One is rational. One is irrational. Yes. Is it always going to be like that? Yes. So, what are rational, what are irrational? Basically, rational is the number you can see the end. You can predict the end. You know, I'm recording everything you talk about is recorded. So irrational is the number you cannot predict the end. For example, 2/5. 2/5, if you put in a calculator, everybody do that. Yes. Put in a calculator is what? 0.4. Can you see the end? Can you see 0.4? Is there the end? No. Is there an end of the number that you know? What's the end of that number? 0.4. 4. So 2/5 is rational or irrational? 2/5 is rational or irrational? Rational, very good. Another example. 1/3.
1/3.
1/3, put in the calculator.
1/3?
Yes. 1/3. 1 divided by 3. So what's the decimal of 1/3? 0.0.3333 infinitive 3, right?
Yes.
Can you predict the end of that number?
No.
Are you sure?
Yeah. Oh, it's 3.
And it's 3.
Because the end is a 3, right?
Yes.
So you can predict the number, the end of that number, so it's rational. Okay, next one. Square root of 2. Put in square root of 2 in the calculator. Put in square root of 2 in the calculator. Square root of 2 is not 2. Put in the calculator.
What were you asking?
What is the number of square root of 2?
The number of square root of 2.
Yes.
Wrong with my calculator.
1.4.
1 point, keep going. 1 point what? 1.4142, blah, 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 blah. Right?
Yes.
So, is there any pattern towards the decimals?
No.
No, that means that number is kind of like pi. The number will keep going on and on, but you cannot predict what's the end, right? So root 2 is what number?
Irrational.
Irrational number. Very good. Root 2 is irrational number. All right. Within rational number, we have other ones. Within rational number, we have integer. What is integer?
Is it like negative positives?
Number.
Integer are whole number. Very good. Integers are whole number. So within all the whole numbers, we have, I'm sorry. Within those integers, we have whole number, which is going from 0, 1, 2, 3. So all those positive or all those unnegative number, okay? A negative number.
What does that say?
What?
The first arrow.
Whole numbers.
Huh?
No.
Integer whole numbers. 1 over 3.
What do you just?
The one he just pointed at.
Whole number.
Whole number.
Whole with the number thing. Whole with the number thing.
You act like a cartoon character for real.
What did you just call me? Guys, you really called me a monkey, bro.
That's crazy.
I called you a cartoon character.
I'm not the darkest person in the room. You just called me a monkey, like.
Because you're racist.
Bad. I like a
Oh,
face tone.
All right. So if you look at that Venn diagram, the biggest section is real number, anything that's not imaginary. So real number will be divided into rational and irrational. Rational is the one you can predict the end. We just use those examples, right? You can predict the end. And then irrational is the one you cannot predict the end. A lot of square roots or cube roots are irrational. And also the most common one is pi. Pi is 3.14 with unlimited end, right? And then within the rational number, we have integer, which is positive, 0, and negative whole numbers. And we have whole, which are non-negative numbers. And then we have natural numbers are just 1, 2, 3, 4, 5. Okay, that one you can actually exist with your finger and keep counting.
Wait, so what does the middle, that's H?
Workout is not work. All right.
Oh.
So look at TV. We have this, right? What are those means?
That's it, easy at the end? What is that?
Well, that's like
X.
ancient languages right there.
Okay. If you look at these, remember earlier we have rational, irrational, whole number, integer, and natural number. They all have a letter represent each set. We have Q. We have 2, Z, W, and N, right? Q is rational, and then 2 is irrational, and Z is integer, and W is whole, and N is natural. So the notation actually means this little line means the set of number X such as, so this little line means, okay, what X can be with this condition, okay? So X will be bigger and equal to -3 and smaller equal to 16.
Wait, Miss Shane, W is ratio?
W is whole number. Okay.
What?
Whole number. And it's
It is in your book. It is in your book.
It says neutral or natural.
Natural.
It was rational.
And
What
then,
does he mean?
what does this mean?
Integer.
This is like a sideways W or sideways M. So this means, okay, X belongs to, or X is an element of the entire set of given numbers. So Z is integer. So X is not any decimals. X is not any fraction, but X can only be integer. That means X can be -2, -1, 0, and all the way up to the range of X, which is -3 to 16. Does that make sense?
Yes.
Okay.
What's W?
Okay. Example number 1. Look at example number 1 and let's just do the guided practice, okay? So in the guided practice 1A, it says, okay, we have a set of number like 1, 2, 3, 4, 5, and then blah, 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 okay? So how can you use the notation to write this set of number? So first, we need to get what? Our bracket right there, right? We start with x. X is any type of number, and then you draw a line. So this is the starting point. This is starting point. Then let's look at the range of the x. Those numbers starting from when? Where? Those numbers starting from where? That's right. Those numbers starting from 1, and then you go all the way up, right? Is there an upper limit of x? Is there an upper limit of x? Well, dot 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 means you keep going.
What is this called, Miss Jane? What is this little math?
It's a
Subset.
set builder notation.
Subset.
Okay. So that means our x must be bigger and equal to 1, right? That's our range for for x. So after you write the range of x, you put a comma there. Then you have to write what set of number x belongs to. So if all the number is going from 1 all the way up and all whole numbers, what type of numbers are these? Are these all rational numbers, irrational, integer, whole numbers, or natural numbers?
Irrational integers. Whole numbers.
Which one?
All of them.
Irrational.
Irrational.
That's right. They're all not irrational. They're all rational. However, you want to try to find the most specific one. Okay, because rational numbers include all natural, integer, and whole number, right?
Yeah.
So you want to use the smallest range for those numbers.
Which that case is 1.
Which is if you start at 1 and go all the way up, and all those numbers are whole number, then what kind of numbers they all belong to?
The first one. 1. I'm kind of confused. I don't know how to answer that question.
Okay, let's do that.
Like, what are you exactly talking about though? Like, when you say
What I'm talking about, you see those letters, right?
right?
So we have integer, we have irrational, rational, integer, whole number, and natural.
Right.
So these numbers belongs to which subset? Which one fits the criteria of this number the most? The number 1, 2, 3, 4, 5. 1A, question number 1A. On page 4. They are natural number, that's right. Because yes, they all belongs to whole number, they all belongs to integer, they all belongs to rational number. However, the most specific one, the smallest range, is natural. So that's why we put down x with the sideway m or sideway w,
So that means
natural, which is n. You see that?
Okay.
So when you write a notation, there are 2 parts. One is the range of those numbers, and the other one is what type of number they belong to. Yes.
So the x and
Okay, let's take a look at number 1b. So our question is, x is smaller or equal to -3, right? So we have the range already. If you write our notation, we start with bracket, with x and line, and then we have our range. X is smaller or equal to -3. However, what is the subset of x?
So that E is like a subset?
like an element.
Yeah.
Okay.
What letter? What letter should we put down? Does it give us any specific number? In the question, does the question give us any specific number besides the range?
No.
No. So that means we don't know what kind of number they are,
So it's
right?
irrational.
So they're all rational, very good. They all should be rational because anything's possible. So we have to choose the rational, which is the R. Make sense?
No, it doesn't make
I
sense.
thought
I
rational
thought
was
rational was Q.
Yeah.
Oh, what did I put?
You said R.
Oh, I mean, not rational, real number. Sorry, real number. My bad.
But where's real number on it? Natural? Wait.
Okay, real number are the number that include rational and irrational. My bad.
Wait, so
That's what I mean. Real number, you don't know what kind of number they are, so all the number it should be included.
So rational, irrational is what?
So the biggest set is real number.
Biggest.
Any number that's real that we can write on the paper or we can calculate is real. Then within real, we have rational and irrational. Rational is the one with the definite end of the decimal, and then irrational is the indefinite end of the decimal. Okay? So the biggest range, the biggest set is real number besides the imaginary. Okay, so that's example 1. So interval notation, example number 2, is something that we learned before. So basically, interval notation, it kind of gave us the range of what number goes to one number. Let's take a look, just look at example here, and then let's take a look at the guided practice. So, write this down. If you see parentheses, okay, if you see parentheses, that means that number is not included. For example, when do we use parentheses? 3 and infinity, or negative infinity, and then -2. So what does that represent? The first one means, okay, the range of the x, of the number, goes from 3. However, that number 3 is not included in the set. So it will be smaller than 3, and then the largest number will be infinity. So whenever you see an infinity, it will be a parenthesis next to it because we don't have a set number to it. So if you see this notation, you see 2 numbers, right? You see 2 numbers. The first number is always the lower range. That's the next number. The second number is always the larger. Okay? So that's why when you look at how I write the notation out, you see the range. 3 is in front of x. 3 is smaller than x. And then in positive infinity is bigger than x. Okay? That makes sense?
Yeah.
So for the second one, if you write out the range as bigger, smaller than, it will be negative infinity, smaller. Oh, no, sorry, we don't write negative infinity. My bad. So it will just be x is smaller than -2. Because if you don't, negative infinity just means at the end, it doesn't have a range. It doesn't have a set number. Okay? All right, so parentheses, that means the number is not included. How about bracket? If you see bracket, means that number is included. So
parentheses, not included.
Yeah.
Or what's it called?
Bracket.
Brackets is included.
That's right. So I'll give you the same example, okay? So if you have the example as the first one, you're going to see 3 parentheses, infinity. Infinity always have parentheses, okay? And then parentheses, negative infinity, and -2 bracket. So what you're actually looking at is 3, but this time the 3 is included. That means 3 is smaller and equal to x. And then then the x is smaller and equal to -2.
What's the goal? What are we trying to solve?
Okay, so it is important when we actually learn the domain, you need to identify the domain and range of the function. You have to see from what number to what number, so that those notation will help you visualize and help you to draw the graph. So yes, it seems like kind of useless right now, but it's actually very important. Okay, without knowing the basic, just like A, B, C, D, those are the basics. You just have to know.
This is basic?
This is the basic for
Man, Miss
the
Chang,
function.
I still don't
I
understand.
It feels like that, but it's like when we keep on, like, if you keep on going, I feel like it's gonna click and we'll be fine.
No.
Well, this is what me.
Isaac.
I think it is.
It's bigger than time.
Okay, so there's a last sign that we need to talk about. Come on. The last sign we need to talk about is a U. It's kind of look like a U. But that U means skip. Okay? That's not its official name, but that's what I tell them. Okay? This U read as union, means basically skip. So, add function. So you have a function. You may look at like something like this. Okay? Then it's like skip the part. And then continue somewhere else. Okay, how do we represent that skip part, the empty part? We use the union. We use the U. Yeah, it's kind of like a U. Okay? All right. Let's just practice this notation together. Let's practice this notation together so you will understand better how to write this. Let's do 2A. Can I move on? Can I erase this?
Everybody.
Yes.
Let's do the guided practice 2A. 2A on page 5. So,
Oh my God.
-4 smaller or equal to y and smaller than -1. Everybody, spend a minute, try this one out. We're going to work at this together.
Man, I don't even start the problem.
So what are we trying to do, Zach?
We're trying to trench that into our notation. The bracket, the parentheses. Okay, so we have two numbers here, right?
So,
What are the two numbers?
4 and 1.
4 and 1?
-4 and 1.
-4 and -1. So that means we have a parentheses, separate them. What's in front of the comma?
For the comma, what comma?
Oh,
The
comma.
little E. You talk about the.
This comma. This is a little comma. What's in front of the comma?
-4.
-4, very good.
-4.
So the first number go first, and then what's after comma?
-1.
-1. So number, comma, number just means, okay, those are the range, okay? The smaller number is -4, the bigger number is -1. Then we need to decide to go with parentheses or bracket. So -4 is parentheses or bracket?
Parentheses.
Right.
Bracket.
Wait a minute.
The first one, -4, next to -4 should be a bracket because right here, you see, after -4 is a smaller and equal to. So whenever equal,
Smaller and equal to isn't a bracket.
no, when you have the equal to, it's a bracket.
Okay.
Oh, okay.
So when you have the equal to, it's a bracket. Then we see a smaller than, right?
Parentheses.
It's a parenthesis because there's no equal. Easy as that. All you have to do is put the number down. If there's an equal sign, that's a bracket. If there's an equal sign, it's a parenthesis.
That's all we're supposed to do?
That's it.
Like literally, that's
That's it.
Yeah, it's a comma.
It's a comma.
Wait, can you re-explain what you just said, Miss
That's
Chang? My brain was really running loud.
Okay, 2B. Let's do 2B. So A is larger and larger equal to -3. Okay.